Welcome to Get Your FRQ On. This question is from 1998. It's question 4, and it is calculator active. In the question stem, we're given a function f, and the only thing we know about f is f of 1 is equal to 4, and we have an expression that gives the slope to the tangent line of f at any point x, comma y. And in part A of the question, we are asked to find the slope of the graph of f at the point where x is equal to 1. So again, in the question stem, we're given that f of 1 is equal to 4, and we have a formula for dy dx. It's 3x squared plus 1 over 2y. To get the slope of the tangent line to the graph of f at x equals 1, we just need to evaluate dy dx, substituting 1 in for x and 4 in for y. If we do that, we get 1/2, so the slope of the graph of f, or the slope of the tangent line to the graph of f, at the point where x equals 1 is 1/2. In part B, we are asked to write the equation of the tangent line to f at the point 1, 4, and use it to approximate f of 1.2. So we just found that the slope of the tangent line was going to be 1/2 at 1, 4, and we know the x and the y coordinates at the point we're interested in, so we can just write this equation in point slope form, and we get y minus 4 equals 1/2 of x minus 1. Now to use that to approximate f of 1.2, we can just replace y with f of 1.2 and x with 1, x with 1.2, and then evaluate everything that's not f of 1.2. So f of 1.2 minus 4 is going to be close to 1/2 of 1.2 minus 1. Simplifying that, we get f of 1.2 is equal to 4.1, or approximately equal to 4.1. In part C, we are asked to use the initial condition that f of 1 is equal to 4 and separation of variables to solve the differential equation dy dx equals 3x squared plus 1 over 2y. So if we set this up for separation of variables, we have dy dx equals 3x squared plus 1 over 2y. This implies that 2y dy is equal to 3x squared plus 1 dx. Integrating both sides would leave us with another true equation. If we find antiderivatives for both sides, we get y squared equals x cubed plus x plus c. Now notice we have to solve this for y, so having y squared doesn't quite cut it. So taking the square root of both sides would require a plus or minus, but we do need to solve for c as well. So using the initial condition, y is equal to 4 when x is equal to 1, 4 squared equals 1 cubed plus 1 plus c. We can get c is equal to 14, and now if we take the square root of both sides, we have plus or minus the square root of x cubed plus x plus 14. Now because we have the initial condition that f of 1 is equal to 4, and 4 is a positive number, we need to make sure we choose the solution here where the output would be positive, so we ignore the minus sign here. And the solution that we're after is the one with the positive version of that square root, so f of x is the square root of the square root of x cubed plus x plus 14. And not surprisingly, in part D, we are asked to use the solution we found in part C to find the actual value of f of 1.2. All right, so f of 1.2 would just be the square root of 1.2 cubed plus 1.2 plus 14, which at this point you could leave it like this, but it is a calculator active question, so you could also use your calculator to do this. And you get f of 1.2 is approximately 4.114. Now, because it's a calculator active question, you should make sure that the reader knows what you've asked your calculator to do. So this expression up here should be in your answer regardless. Right? It can show up here. Notice it still shows up here, But you shouldn't just write f of 1.2 equals 4.114. You risk not earning all the points that way because it's not clear what expression you evaluated or asked your calculator to evaluate in order to get that answer. So you should have the actual expression in your work somewhere just to make sure that you get all the points.